Welcome. All right, here we are. So we're all set. Let me unfreeze this so we can look at this, and we'll go ahead and hit this partial fraction starting. Hopefully it wasn't terrible, but you might have had some issues. So there were two types of problems. The first set was decompose the problem into partial fractions. The second set was actually doing the integration. So let's deal with the stuff that was the lower numbers, and then we'll deal with the bigger numbers. Was there anything from the lower numbers, just taking things and pulling them apart into single individual fractions? What do you think, Hayden? 2b? All right, let's take a look at 2b. Wait a minute. That one, did I assign that? I didn't? 2a. Okay, yeah, because I look at it and I'm thinking, I don't think I did that. That one's kind of what we're going over today. So if you had issues with it, it's okay. We'll cover that stuff today. So anything else that I actually assigned? Okay, so what about the second part, the doing the integration? So it's straightforward? Yeah, what do you think? What do you think, Michael? Yeah, let's take a look. So good to have at least one under our belts. So x minus 4, just a sec. So this is number 12. X squared, is it 5x and 6? Yeah, 5x and 6. So, of course, what you're going to do is rewrite this and factor the denominator. And by the way, on the quiz, so today's quiz is pretty straightforward. It's just a single fraction that you have to decompose into. It's like the first half, where you're just doing the decomposition. You're not doing the integration. But the decomposition is, it's good to go over that. So what I would do is I would set this up like this. If you have 2 or 3, however many you have, just write a fraction for every factor in the denominator. So there's my 2 factors. And then we're just going to multiply everything by the common denominator. Hopefully this isn't going to throw you if I just write it like this. But if you're not sure why this turned into this, let me know. Essentially, you're just multiplying by this common denominator and canceling anything that cancels from those 3 fractions. Okay, now that we have that, what I would suggest, and you can, like I said, you can do it the way the book does it. That's totally fine, using some algebra. But I really like this little trick that I've learned actually somewhat recently. Probably 10 years ago is when I learned this trick, and that is you pick your values of x to correspond with those factors. And so if we let x equals 2, then you get -2 on the left and 0a plus -b. I guess I should just make that a minus b, right? So if you're clever about how you choose your x's, because this should be true, the a and the b should be true for all values of x, you can pick a value of x and actually simplify the whole process. So b here is 2, and then we'll pick another one, x is equal to 3, and that gives me -1 on the left and a on the right, plus 0b, of course. And so a is -1. So that's so I guess then that brings us back to the original problem. Let me write it down and then I'll see if there are questions, because this is kind of the important step. The rest of it you should be able to do. So this is -1 over x minus 3 and 2 over x minus 2. So let me pause, see if there's anything there that caused problems, because this is like the most important step. The rest of it I think you can do, but so make sure we get this down. Any major problems? Okay, so let's go ahead and now the rest of this is just doing the antiderivatives. And these antiderivatives are nice and easy. You get negative natural log of x minus 3 plus 2 natural log of x minus 2 plus c. And then if you want to be cool, which you don't have to be, box this. This is perfect. This is great. But if you really want to go the extra mile and make it look really pretty, you can do this, x minus 2 squared over x minus 3. And that's because I'm using the rules of logarithms. In particular, when you have a coefficient in front of natural log, that becomes, you can move that inside as an exponent. And then when you're subtracting two natural logs, it turns it into a fraction. What do you think, Eli? Oh, it's a definite integral? Oh, you're right. Well, that makes, yeah, so that what I just did was irrelevant. Uh, I mean, the whole simplification thing, because we're just going to plug in the numbers anyway. So let's put those numbers in. You don't need the plus C. Sorry about that. Let's get rid of all of this. I got a little bit ahead of myself. Uh, Here, let's get rid of that as well. And this. Okay, so that means that we're going to have this evaluated from x equals 0 to x equals 1. And so this is the natural log of, let's see, 1 minus 2 is -1, so -1 squared over 1 minus 3 is -2. Do I have that right? I think so. And then I'm going to subtract off the natural log of what I get when I plug 0 into there. So -2 squared over -3. I think I got all that right. So this will be natural log of 1/2. Because of the absolute value, the negative will go away, minus the natural log of, 4/3. 4/3. I probably should have just left it like, oh, what am I doing? Oh, no, I'm doing it okay. I'm doing fine. Sorry. Just took a minute to, you could have done this way as well, just so you know. And then I might as well combine these as long as I'm in the habit of doing this. So this will be the natural log of 1/2 over 4/3. Isn't that beautiful? And so that's equal to the natural log of 3/2. When all is said and done, whatever the decimal equivalent of that is. So natural log of 3/2, I don't know offhand what that would be, but you could do that on your calculator. So is that, get it done? What do you think, Red?
When you go to the start of the problem, say that you have x minus 4, that will like determine if the fraction is negative or positive, or it's always going to be positive.
I'm not sure what you're asking. Which fraction?
The partial fraction.
This partial fraction here? Okay, so the x minus 4. Okay, the x minus 4 will determine the values of a and b, and the a and the b might be positive or negative depending on the x minus 4. So in this case, b was positive and a was negative, and so that's why this is -1. So it's whatever your a and your b end up solving for. So yeah, so it's always, you solve for a and b, or a, b, and c if there's a, did you have any with 3 factors? Oh, you didn't? Oh, well, you got one on your quiz with 3. Well, huh. It's okay. It's okay. It'll be fine, I'm sure. Maybe we'll do this one as a group, just because, yeah, I always hate it when I do make it harder on the quiz. I like to make the quiz easier. I thought this would be fun. I got to remember that when I think it's fun, it's probably not fun for you. Well, let's go ahead and we'll do this. Oh, we'll talk about homework afterwards. Yeah, sorry, I should have talked about that at the beginning. But so we need to iron out some kinks, which we will do with the whole homework thing, that the shift in the way I'm going to collect homework. But I appreciate those of you who have been doing your best to upload stuff. I will talk more about that after the quiz here. So try this out. We'll go over this, and I won't collect it. So that'll be a compromise, since it is a little bit harder than the stuff you had on your homework. And here is the actual thing for those watching online. There. Oh, I'll just Oh, and sorry about the misspelling, Farctions. You can correct that if you'd like. Here, I'll correct it up here. There, typo. Oops. All right. Beautiful. Okay. All right, well, let's go over this and see how you're doing. Hopefully you're able to figure out how to factor that denominator. Just in case, let's just remind you that this is going to be x times x minus 2 times x plus 2. So once you have three factors, you're going to decompose this thing into three fractions. So those three fractions, let's see if I can just show you what I've got over here. There they are. So it's a over x, b over, you might have used a different order for yours. It's fine, as long as you have these three fractions. So if you got to this stage, you're doing great. You probably have it correct. Anyway, let's see where this goes. I'm going to multiply everything by the common factor, the common denominator of x cubed minus 4x. And when I do so, the left-hand side, of course, just becomes the numerator. On the right-hand side, I end up with all of these extra sort of factors. So here, I don't want to show it off too much. But for example, a times this denominator ends up becoming a times the other two factors. So because the x will cancel. With the b, it's the x plus 2 that cancels, and so you're left with those two factors. And with the c, it's those two because the x minus 2 will cancel for that one. So if you got to here, by the way, every step that you got on this one, you should give yourself a big thumbs up, as you did a great job. Okay, so because this one's hard, I'll try not to do this. I guess I just got excited this morning when I was in my office a little early and I'm typing and I'm like, oh, that'll be fun. No, fun is not what you're looking for. Okay, anyway, here's how I solved this one, is I just picked the three most obvious values for x. When you plug x equals 0 into everything, you get negative 16 is equal to negative 4a. Those, of course, become 0 because b times 0, c times 0. And so that gave me a is equal to 4. When I plugged x equals 2 into all of this, hopefully I did my arithmetic correctly. This became 0 because of the x minus 2 factor. This is 0, but this is c times 2 times 4, which is 8c. On the left, I got 24. Once again, I hope I did my arithmetic correct. And so that gave me c equals 3. And then when I picked x equals negative 2 in order to zero out those two terms, I ended up with 16 is equal to 8b, which gave me b equals 2. So can't scroll there, but I can scroll here. There it is. So there's my final answer. There's my three factors. And then now, or my my fractions. Now, of course, if I was integrating this is almost trivial. It's just going to be, 4 natural log of x and 2 natural log of x minus 2 and 3 natural log of x minus, or x, that's x plus 2. X plus 2, x minus 2. All right, so what sorts of questions do you have about this? Does it look okay? What do you think, Ethan? Oh,
Same numbers, but like
okay, so if you did this, just a minute, or no, change that just a sec. Yeah, if you change the order of these things, then of course your A, your B, and your C will be different from they'll be the same three numbers. And in the final answer, that's what matters. So if your final answer looks like this, then you're good. Whatever order they're in. Anything else? Other concerns? So I can did you all correct your quizzes? If you corrected them, then I can just assume that they're all 100 now. And so I'll make sure I put that into my gradebook. Okay, so we have two things to deal with today, two problems. So the first problem, I could go to whoops, that's not it. I could go to the PowerPoint, but it's more fun to just go ahead and do this. So here's the first one. And then the second one is a little bit harder than this. And then we'll be all set to do all of the homework and we'll move on. Let's see, is there anything else in this? Oh yeah, there is, but. Okay, so let's deal with this first one. So this one, this is an improper fraction. Let me remind you what an improper fraction is. I'm just going to back up for a second and write something like this, 7/3. That's an improper fraction. So back in elementary school, or maybe it was early middle school, you learned that 7/3 was actually 2 plus 1/3. Now, how do I know that it's 2 plus 1/3? It's because I can do my division. 7 divided by 3 is equal to 2 remainder 1. I don't know if you probably at some point you learned about remainders, didn't you? That you can put 2 3s into 7 and there's a remainder of 1. So this sort of thing is the way that we would write the fraction 7/3. We're going to do the same thing down here. This is improper because the power in the numerator is greater than or equal to the power in the denominator. Anytime that happens, you have an improper fraction. Now, back here, this gives us a hint as to how we're going to do this, is we're going to do some division. So specifically, you're going to divide the top by the bottom. Now, in practice, when you're dealing with polynomials, the way you're going to divide is you're going to use long division. I know, it's like a blast from the past. I know you're probably feeling so much joy right now. So here's how this works, is you put the bottom of the fraction outside the division symbol, and then the top of the fraction goes inside. And what we need to do is we need to stretch this out and put every possible term, even the zero terms. So if there are any, like this is a polynomial of degree 3, which means I better have x cubed, x squared, x, and 0. Just as placeholders, this is akin to what you would have done if you had 70 divided by 3. You would do this, 70 divided by 3. The 0 is a placeholder, even though we're not going to do the division like you do 3 times. Well, oh, here, let's just review. How do you do this? Well, you ask yourself, how many times does 7 go in, or 3 go into 7? So you do term by term or place by place. 3 goes into 7 2 times, and then you say 2 times 3 is 6, and subtract. Now, I guess that it's been 50 years, probably more like 48 years, since I learned how to do this, and I realized that the techniques change. And so you might have learned long division a little bit different than this. If you did, I don't know what to tell you, because I don't know how to do long division with polynomials if I don't do it in that way. So hopefully you can catch on quickly. Anyway, you drop this down here, and then you ask yourself, how many times does 3 go into 10? 3 times 3 is 9, so that's what I'm going to use. And then you do this, and that is the remainder of 1. So 70/3 is 23 plus 1/3 is what I'm getting out of this. So we're going to do the same thing, but we're going to do it with polynomials. I know it's painful, but we can do this. Fortunately for us, it's actually somewhat more straightforward, at least I think so, than doing this. There's not as much guesswork, in the sense that I can look at this and I can ask myself, what do I need? All I care about is this leading term. So I'll ask myself, what do I have to multiply that leading term by to get x cubed? And the answer is I need to multiply it by x. X times x squared is x cubed. That's all you care about. All the rest is fluff, I guess. I don't know. So I'll write this down. X times x squared is x cubed. X times 4 is negative 4x. So notice what's happened here. And once again, if you're not as familiar with long division, here's how it works. You take that thing that you say, okay, x times x squared is x cubed. That's all well and good. But you need to multiply that x times everything over here and stretch it out down here so that it all lines up in the proper place. And so there's what I get. And then I'll do, just like I did up here, I subtract. So here it was 7 minus 6 equals 1. Now what I'll do is I'll do that whole polynomial minus the red polynomial. So let's just go ahead and do this. And this is there. It's hard to do because there are going to be double negatives like this. So let's just walk through carefully. I have x cubed minus x cubed, which is 0. Then I have 0x squared minus 0x squared. I guess I could put that in there, which is also 0x squared. You really don't have to write that down. I'm just putting it here to emphasize that I am subtracting everything. And then 0x minus negative 4x is positive 4x. So that's going to be the thing that's going to kill you, is when you have to subtract a negative and you get a positive. Okay, so just as with this, I'm going to take the next term, drop it down. So let's do that. Put this down here. And then ask myself the question again, how many times does x squared go into 4x? It doesn't. And so we're all done now. So my final answer is x, and the remainder is 4x. Whatever's at the bottom is going to be your remainder. So getting back to here, let me just write this down and then we'll see what sort of questions you have, because this is overwhelming. It is hard. It's going to take you a little bit to get used to. So what I have here is it's x plus 4x over x squared minus 4. So just as up here, when I got 70/3 is equal to 23 plus the remainder over 3, here I have this stuff is equal to the quotient plus the remainder over the denominator. So let's put it all up there, see if that makes sense. What do you think? We're reasonably happy. I know you're probably not thrilled. What do you think, Red?
Where did you get that minus 4x for the division?
Oh, so okay, yeah. Let's see. So going back to the here, just a minute. It's just going to take a sec. How can I do this? Just a minute. Oh, why not? I'll do that. Okay. Just a sec. Okay. Come on. Okay, there we go. There. Okay, so there's that big blob there. Okay, so we just have to back up a sec if you want to answer that question, just to make sure that everything's kosher. So the first thing is, do you understand where this x came from? Okay, because x times x squared is x cubed. So then the next step is we say, okay, we're actually going to multiply this x times everything in these parentheses. So what is x times x squared, Red? It is x cubed. Very nice. So that's where that came from. But I have to multiply x times this as well. What's x times negative 4? And that's where the negative 4x comes from. And there it goes there. And then we do the subtraction, which makes that minus 4 to be a positive, and then drop the rest down. All right, thanks for enduring. Are there other issues or questions? Yeah, so the long division, it's going to be a bit tricky, but hopefully you can overcome it. Okay, so next, let's deal. The rest of this is straightforward because you've already done this. So next step, of course, is to deal with that fraction, 4x. So I'm going to blow through this pretty darn quickly. That's going to be a over x minus 2 and b over x plus 2. Hopefully that doesn't throw you. Pretty straightforward. So this is 4x is equal to a x plus 2 plus b x minus 2. So I know I'm skipping steps here, but hopefully you're familiar enough with this that you know, factor this, put the two factors down here, multiply everything by x plus 2 times x minus 2. Some of this cancels, and we get this. Now we just pick numbers like x equals 2, gives me 8 is equal to 4a, which means that a is equal to 2. And if you choose x equals negative 2, you'll get negative 8 is equal to negative 4b, which means that b also equals 2. I'll just pause. I know I'm blowing through this, but this is old hat. This is old stuff. This is easy. Well, might not be easy, but it's older. Okay, and then the final step, of course, is to take this and say, okay, then this whole thing, go down here, is equal to the integral of x plus 2 over x minus 2 plus 2 over x plus 2. And then, of course, the rest of this is straightforward. Whoops, I almost blew it. X squared over 2 ln x minus 2, whoops, plus 2 ln x plus 2 plus c. Box it up, be happy. I know I blew through the end game very quickly, but I needed to, sort of move ahead here. Because the next example, we have one more, actually just one more example. I may have made a mistake in having 2 examples today, because the second one is really nasty. What do you think, Hayden?
So the long division integral should be the same as the multiplied, right?
I'm sorry, what you mean this one? Is that what you're talking about? These are the same.
I just went back into the improper fractions for fun, and
What do you mean? What do you mean? What are you saying?
I did the further partial fraction substitution for the improper fraction integral.
Oh,
I did not get the same effect.
interesting. Let me see. So you're saying you no, let me just see what you mean. I want to understand. So you started with this, and then what did you have over here? Okay. So, this is going to, I see. Okay, so that means you have x cubed is equal to ax. I see a problem with my method. So I got so excited about the fact that this is a shortcut that I neglected one crucial piece of information about this, and that is so that this polynomial has to equal that polynomial. And so, yeah, if you use the shortcut that I've been showing you, it really doesn't, it doesn't really illustrate exactly what's going on. So give me a sec here. Negative 2b, a plus 2b. Okay, so here's the correct version of how you're supposed to do this, is you collect like terms. So we have ax plus bx, which is a plus b times x. And then you have negative 2a plus 2b as the constant. So clearly, if you compare left and right, I have negative 2a plus 2b is equal to 0 because there's no constant over here, but there's also no x term over there. And so that means a plus b should also equal 0, but there's this thing, x cubed, and there isn't an x cubed on the right. And so this can never equal one another. So this, I guess, is a deficiency with this shortcut that I hadn't. Thank you for pointing this out, because this is not, yeah, it's no good. So I guess just to point out the way that the book would want you to do this, let's just take a look at this. So yeah, you can't do that. It's got to be a proper fraction. Improper fractions don't work with this particular method. So let's just take a peek at how the book would have you do this. So just so you can appreciate the shortcut. So if we did this, we get 4x is equal to a times x plus 2 plus b times x minus 2. Okay, so I'm just taking that thing down there and multiplying through. Oh, it's the same thing. So here's how the book, and actually this is all totally correct. So I'm showing you a shortcut that now I'm kind of regretting a little bit. Not too much though, because the shortcut is so much quicker. But let me show you, and also easier to implement. But here's how I would do this if I did it the book way, is I would recognize that this on the left is 4x plus 0. On the right, a plus b times x plus 2a minus 2b. And now lining up the coefficients, a plus b is equal to 4, 2a minus 2b equals 0. Two equations, two unknowns, I don't know how you want to solve this. Personally, I am a big fan of elimination, which is, here, let's see, get rid of that. Elimination is where you take one of the equations and rewrite it. 2a plus 2b is equal to 8. So I multiplied everything by 2 and then just leave the other one alone. And the way I rewrote that was in such a way that if I add those together, it eliminates the b. And that gives me 4a is equal to 8, which is a equals 2. And then you can plug that back into maybe that equation to get b equals 2. So that's the correct way to do this. This business down here is a shortcut, but it only works if you have a proper fraction. Improper fractions doesn't work. So thank you for, I'm glad that you experimented, actually, because it helps me to realize that I need to be more careful in the future about this. So this works, it only works when you have a proper fraction. And that's a proper fraction. All right, any other observations? Because that's beautiful, really, I'm thankful. Okay, another one. That's right. Yeah, and even if you didn't do the long division, like this never works. You're never going to be able to get this to work because you have on the left x cubed, on the right there is no x cubed, or maybe you'd have 0x cubed. And so if you compare the coefficients left and right, you end up with 0 equals 1, which is not true. So that's why that, yeah, no good. So let's get rid of all that because I don't like it. It's gone. All right, anything else about this before we go on to the nightmare example? All right, everyone's happy? Well, reasonably happy, like, well, we're gonna have to do this. Yeah, we'll have to do it. Okay, so I'm beginning to wonder if this was a bad idea, but what I did was I took all of the difficult stuff that you're gonna have to do on your homework today, and I combined it into a single example, and that's this example here. Okay, now don't get panicky too quickly. Let's go ahead and take a look at this and see if we can factor. So ignore the numerator for a minute and let's just deal with the denominator. So here I'll show you the whole thing, but let's factor this denominator. Take a minute and see if you can factor this. 4x cubed minus 12x squared. So see how far you can get with factoring that. And we'll take it in stages. I mean, that's the way you do this, right? Did I ever submit my attendance? I don't think I did. Let me submit it now. Nice. All right, so let's do it in stages. That is to say, we're going to do a little bit at a time. And Carson, you get to be first. Can you factor any of this? Is there anything that's obvious that you could do? X squared, very good. So I've got x squared, and I'll put the rest of the stuff here. That's x cubed minus 3x squared plus 4x minus 12. Excellent. All right, we're on our way. All right, now there's another thing that you can do that maybe you've forgotten about in the distant past. But so I won't pick anyone out of the group here, but does anyone remember the technique to factor something like, oh, you got something? What do you think, Americo? What do you mean by that? Yeah, grouping. So it's called factoring by grouping or splitting off variables, if you want to call it that. Very nice. So here, let me just, in case you're not as quick as Americo, let me just group these for you so you can see what the groupings are. X cubed minus 3x squared, and then 4x, whoops, that's supposed to be an x, minus 12. So there are the groupings. And you're just going to factor each group now. So let's find out what happens when you factor the groups. Let's find another volunteer. Michael H. back in the back. Can you factor x cubed minus 3x squared? Very nice. So you factor an x squared out of that. And then we need another volunteer. Give me a sec. Boop. So Hunter, what about the 4x minus 12? What can factor out of that? Yeah, 4. So that becomes 4 times x. What? Amazing. The same, look at that, x minus 3, x minus 3. Isn't that cool? So I can factor that out. So x squared times x minus 3 times x squared plus 4. We're almost done. Actually, we are done because we can't factor x squared plus 4, can we? Yeah, we're all done. Okay, so here is sort of the nightmare scenario that we need to deal with. And that is, how are we going to figure out what the partial fractions are going to be for this? Now, don't worry, this is going to work out relatively nicely when we get done. It's going to be, I picked numbers that would be reasonably pretty. But let's write down all of the different factors that we're going to need. Okay, so first things first, x minus 3. I know you probably wouldn't begin with x minus 3, but that's the one that is the most similar to what we've been doing all along. So I'm going to use a over x minus 3. Now the next one is x squared. Now x squared is kind of a funny one because that's actually two factors, x and x. And so I've got to account for both of those. I need to account for both of those x's. And so here's the wrong way to do it, but I'm going to fix it pretty easily, is this. You say, okay, here's one of the factors, and here's the other factor. But that's kind of silly because b over x is basically the same as c over x. And so whenever you have multiple factors that are the same, the way you account for all of the factors is you say, okay, this is going to be b over x. The next one will do c over x squared. If you had a triple factor, like just as here, go down here real quick. Let's say you had this, x minus, x plus 3, whatever, x minus 1 cubed. Then you would do a over x minus 1, b over x minus 1 squared, and c over x minus 1 cubed. So that way you account for all the different ways that you might be combining the x minus 1 factors together. Now this was going to create a pretty ugly scenario if you had a triple factor, so that's why I've avoided that. But up here, this isn't going to be terrible. Okay, so just to recount, and we're going to get to the final factor in just a sec. So whenever you have a single factor, single linear factor, you write constant over that factor. If you have a multiple factor, whatever multiplier you have, like here it's a double factor, you're going to have two fractions, and you just have, each of the different powers of x that you could have. The final frontier is what to do with that x squared plus 4. Well, x squared plus 4 deserves its own fraction. It can't be factored any further. But unlike the linear factors, x squared plus 4 is going to get a linear numerator. That's it. So that's what this looks like once all is said and done. We've got, so just to recap, single linear factor, you know what to do with. Double and triple and quadruple linear factors, which is what this is, you do as many fractions as you have multiplicity for that factor. Quadratic factors that can't be further factored, you're going to write as a linear term over that. Okay, I know it's super overwhelming, but let's see if we can take a deep breath. It's going to be okay. Okay, so let's see if we can put this together. So there's what we're dealing with here. I can scroll back up if I need to. If you're like, oh, I didn't get the factoring. Well, I think we all got the factoring. Okay, so from here on out, The rest is, it's just a larger problem, but it's similar to what we've been doing. We've got all of our factors. Let's go ahead and write this down. I'm going to multiply by that common denominator, which is that denominator on the left, the purple denominator. So let's see, let's put this down here. So on the left, you end up with just that. On the right, here I have to be super careful. Ax squared times x squared plus 4. B, x minus 3, x squared plus 4. Ooh, I don't have a lot of room. I'm going to move this over just a bit. Because this gets kind of unruly. Okay, so let's just explain though, if I multiply by all of these, now remember, you're only going to multiply by x minus 3 times x squared plus 4, which is what this thing is. So when I multiply by that, one of the x's get canceled with the one below the b, but the other x is still there. When I multiply all of that by the c term, I end up with c times x minus 3 times x squared plus 4, because both of the x factors get canceled. And then finally the dx, this is going to be the ugliest, dx plus e. Here, you know what? I'm going to move this down. Hold on a sec. I know you. There. That way we can see it all a little bit bigger. So dx plus e times, this is going to be times x minus 3 times x squared. So just to be clear, if I multiply by all of those factors, the x squared plus 4 will cancel, but you'll be left with x minus 3 times x squared. You know what? I feel like I need to at least pay homage to the thing that I'm multiplying by. Let me do that really quick. I move this over. Can I fit it all? Let me see if I can fit it. So this is kind of bad notation, but you know, we're doing the best we can. So x minus 3, x squared plus 4. So essentially I've multiplied every fraction here by this stuff, and that stuff is the same as the purple denominator, so that's why this just cancels. And then you just cancel the appropriate factors in each of these 4 fractions here. So far, okay? Maybe? It's hard. It's hard. This is hard. But we're gonna carry on, aren't we? Okay, so now let's be clever. Unfortunately, whenever you have quadratic factors, we can't be clever enough. But we can be sort of clever. What I mean by that is we're going to have to do some algebra, some solving of 2 equations with 2 unknowns in just a bit. But at least for now, we can be a little clever. And that is, we're just going to say, okay, let's say that we let x equal 0. In that case, I get negative 36 on the left. And on the right, everything will cancel that has an x factor. The only thing that will not cancel is the c. So the c ends up becoming negative 12 times c. And so that tells me that c is equal to 3. Well, that was convenient, wasn't it? I can also do the same thing for x equals 3. So if you let x equals 3, okay, I'm going to have to pull out my calculator at this point, but I will do that momentarily. First of all, let's deal with the right-hand side. If you let x equals 3, this factor is 0, this is 0, this is 0. The only thing left is the a, and the a is what, 9 times 13? Is that right? So, sorry, 117? Is that 9 times 13? Yeah, I'm going to have to pull up my calculator anyway, so I better do it. 9 times 13 is 117. So 117a on the right. On the left, bear with me, this is going to take a minute. 5 times 3, or that's 81. 5 times 81 minus 2 times 27, 3 cubed, plus 21 times 9 minus 12 times 3 minus 36. I got 468. I sure hope this divides out evenly. Let's find out. Divided by 117. It does. It's so exciting. I guess because I had prepped this one earlier and I knew what the answer would be. But I sometimes don't write it down the way it's supposed to. So there's my A and my C. So exciting. All right, now, so what do we do about the D and the E? And the, wait, what else do we have? B, D, and E. Ugh. Okay, well, let's find out. So here's what I would suggest we do is we rewrite this whole thing. So give me a sec here. Copy and paste. And from here on out, we're going to have to use algebra, sadly. So here we're going to actually have to do the hard work. But let me just clean this up. So I'll explain. I'm going to get rid of A, and I'm going to get rid of C. So let's see. Hold on a minute. Don't go nuts yet. Okay, so A is 4. And so looking up at the top, so the very top, A times x squared plus 4. That's A times x to the 4th plus 4x squared. So that'll be 4x to the 4th plus 16x squared. So that is where my A ended up. We'll do the same thing for C. So C is going to be 3 times x minus 3 times x squared plus 5. So let's see, that's going to be, let's see, 3, sorry about this, x cubed. So 3x cubed. It's going to take a minute. Minus 9x squared. I'm doing FOIL. Plus 12x minus 3 times 12. That's 36. Okay, so take a minute and see how that works. But basically, just to, I mean, because we're not going to be able to finish this in 5 minutes, but basically all I'm doing here is I'm going to do the algebra to get my A or my B, D, and E. So I'm going to get it set up. I might not finish in the next 5 minutes, but I'm certainly going to, 4 minutes, I'm going to try my best. Okay, hopefully you see the miracle that's going to occur now, and that is that the 36 is going to cancel. I don't know if it's a miracle. Those cancel, isn't that nice? Is there anything else that I can cancel? I'm going to move all of those blue things to the left side. So let's see, what's going to be left? On the left side, I have x to the 4th. Let's see, minus 5x cubed. So just to explain, I took the 4x to the 4th, moved it over, and subtracted it from the 5x to the 4th. And then I'm going to take this negative 2x cubed and subtract off 3x cubed. So I'm just trying to collect everything on the left. And then we have, where am I left with? 9x squared, 16x squared is 7x squared on the right. When I move it over to the left, it becomes negative. So this will be plus 14x squared, I believe. There's 12x on the right. When I move it to the left, it becomes plus, no, it becomes negative. Negative 24x. All right, now what's left over here is the bx, x minus 3, x squared plus 4, plus dx plus e, x minus 3, x squared. Okay, a little bit more cleanup here before we move on, and that is I can cancel out one of the x's. And I'm wondering if I can also factor out an x minus 3. Presumably I can. Yeah, let's see what I can do. Let's first of all cancel an x. X cubed, 5x squared, 14x minus 24. This might be enough. B x minus 3 x squared plus 4 plus dx plus e x minus 3 x. Okay, sorry, I gotta erase this down here. Cut. How much time? 2 minutes. Okay, I'm not going to be able to get the whole thing, but check it out. At this stage, we can use our little trick again, and that is to say that if I let x equal 0 now, then I get negative 24 is equal to negative 12b, because this will be 0 over here, and that gives me b equals 2. So yet another simplification that I can do. So this will be x cubed, 5x squared plus 14x minus 24 is equal to, okay, 2 times 2x cubed, give me a sec here, minus 6x squared plus 4, 8x minus 24 plus dx plus e times x minus 3 times x. Okay, so we could do this business minus plus x squared plus 6x is equal to dx plus e times x minus 3 times x. Okay, so I'm practically done. So x squared, sorry it's going quickly now, but and I'm getting messy. So I better stop writing because it's just becoming a mess. But you can see that I can cancel another x, and then you're left with a trinomial on the left. If you just multiply those out, you'll have a trinomial on the right, and I think you'll be able to line up. Actually, there's almost no algebra to do. I can tell you right now that d is going to be negative 1, and e is going to be something else. But yeah, for sure, d is negative 1. So just one last note is when you get done with this, you're going to have something like this at the end. So most of the integrals will be easy. For example, the integral of a over, you'll know how to do that one. This one's easy, this one's easy. That one is the problem child. That one you can do. If you remember, I'm just going to make numbers up, 3x plus 7 over x squared plus 4. If you have something like this, you can actually, dx, you can actually separate this into two fractions and integrate these independently. The one on the right ends up being an arctangent. Hopefully you recognize that. The one on the left ends up being a direct substitution. U is equal to x squared plus 4, and du is equal to 2x dx. And so that one, so do your best with these. We'll see how things go tomorrow. Homework. Thank you for those who have uploaded. Maybe we can talk tomorrow. Maybe tomorrow should be a catch-up day because this is hard. It's hard. So don't panic. We will do our best tomorrow to catch